Hi guys. So what we're going to have a look at now are the quick quiz questions that we left from earlier on until 10F so that we could look at them in tree diagrams that had our probabilities on the branches. So let's look at question number 1. It's in yellow up here. So in a raffle, 30 tickets are sold and there are 2 prizes. John buys 5 tickets. What is the probability that John wins at least 1 prize? Okay, now there are a couple of ways to do this one. We could use a tree diagram, okay, or we could do it without a tree diagram. I am going to look at it without first, and then we'll have a look at it with the tree. So let's have a look down below. Now, the question is saying, what is the probability that John wins at least 1 prize? So remember, when we're looking at those at least questions, it's 1 minus probability of that not happening. Okay, so the probability that John wins at least 1 prize is 1 minus the probability that John wins no prizes. So we can have a look at that using our information from the last exercise that we did. So the probability that John wins no prizes from our first draw is going to be 25 out of 30. So there were 30 tickets all up. John had 5. So he's got 5 chances of winning, but he's got 25 chances of not winning. And that's where that 25 comes from. That's what's happening in our first draw. Once 1 ticket has been drawn, we're assuming that you can't win twice with that 1 ticket. So we now have 29 tickets in the draw. One of the winning tickets from that 25 is the winner. So we now know there's only 24 other winning tickets in the draw. So our probability that John wins a prize is 25 out of 30 times 24 out of 30, which gives us 20 out of 29. Now that's not our answer, because we want to work out the probability that John wins at least 1 prize. So that is 1 minus 20 out of 29, which we get 9 out of 29. Now, if you can do it that way and think that way, that's going to be a lot easier and a lot quicker. But you don't have to do it that way. You can use a tree diagram. So let's have a look over here. Here's our tree diagram. Our first prize is shown here, and our second prize is shown here. So we've got a win and a lose, a win and a lose, and a win and a lose. So all up, let's have a look. We've got John having 5 tickets out of the 30. So that's his chance of winning, 5 out of 30. His chance of losing is 25 out of 30. Our 5 out of 30 and 25 out of 30 need to add to 1. Now what you'll notice is that chance of losing that 25 out of 30 was the same as what we used over here. This 25 out of 30 here and this one are the same. So if you can think of them without the tree diagram, that works really well. Okay, now we've got our first prize. We're assuming that that's happened, and now we're drawing our second prize. We're going to assume that once you've drawn a ticket, that doesn't go back in, that you can only win once with that 1 ticket. So our 30 tickets have gone down to 29 now. We've only got 29 tickets in there. So if John wins the first prize, he had 5, he would only have 4 left to win a second prize. And there'd be still 25 out of 29 now ways that he could lose. Now, if John lost the first time, you would still have 5 tickets left, and there'd only be 24 other tickets that weren't his left in there, and they're both out of 29. What you'll notice that these 2 fractions here add to 1, and these 2 add to 1 as well. So that's our tree. Now that you've drawn your tree, you could draw the outcomes down the side or your sample space. I'm not going to, because we're going to physically look at what happens across the arms and grab our fractions as we go. Let's look at what the question says. The question said, what is the probability that John wins at least 1 prize? So he can win 1 prize, or he can win 2 prizes. So you could go through and you could work out this probability, these 2 probabilities, plus these 2 probabilities, plus these 2 probabilities, and add them together. Or you could say, okay, there's that at least again. The probability that he wins at least 1 is going to be 1 minus the probability that he wins none. And the probability that he wins none is going to be our loss. So it's going to be 1 minus the probability of a loss, which is 1 minus 25 over 30 times 24 over 29. And you might remember we did that over here again, okay? We took 1 minus the answer to those two, which we're going to work out over here, and we end up with 9 out of 29, which we ended up with over here as well. So there are the two ways to do that first question. Okay, if you want to stop and look at that now, do that. I'm going to have a look at number 2. I like number 2. We talked about this a lot in class. It's a real practical question because we're not often working out the probabilities of buying raffle tickets and winning so much. But in this case, this is something that would be useful because it's talking about blood types. In Australia, approximately 9% of the population has a blood type O negative. So it's not a very common one, is it? If 3 people are chosen at random from the population, we want to find the probability that none has an O negative blood and at least one has an O negative blood. So you can see this at least one is happening quite a lot here. Okay, I'm going to use, instead of 9%, I'm going to pop it into a decimal format because I think that will be a little bit easier on our tree diagram. Now, what I've done is I have used a little key so that you can see what I have done. I've used 0 to represent people with O negative, and I popped a 0 with a little line over the top, so the complement of 0 to mean people that are not an O negative. Okay, so we're looking at 3 different people. So each part of our vertical parts of our tree are our people. So person 1 is shown here, person 2, and person 3. So we've gone just as before, O negative, not O negative, O negative, not O negative, and we've gone along. I've popped it in as a decimal. So we've got 9% of people being O negative. Therefore, because it has to add to 1, 91% or 0.91 are being not O negative. And that's what our tree is going to look like. You can put, again, an outcome or a sample space at the side. Our question said, find the probability that none has O negative blood. So if none have O negative blood, we want the complement of O negative each time. So not O negative, and not O negative. That's the same as the probability of O negative times the probability of O negative times the probability of not being O negative. Sorry, I've confused that up there. That's why my key is great at the top. Remembering O with the bar is the complement of it. So yeah, not O negative for each of them. And that's going to be through this part of the tree here. So we've got 0.91, 0.91, and 0.91, multiplying those together. And we get this number here, 0.753571. That's fairly easy. You could actually easily have worked that one out without a tree. Okay. Our second one said, find the probability that at least one has O negative. Now remember, at least one is 1 minus probability that none of it happens. So the probability that we have at least one being O negative, it's going to be 1 minus the probability that none are O negative. Now, the probability that none are O negative was our first question, so it's 1 minus that one. And that gives us our answer there. Okay, it's time to look at our third question that I've got in pink, and I've recopied that over here to the side so that we can not have to scroll back and forwards. Okay, this one in class caused a little bit of confusion with people when we were drawing the tree diagram. We'll read the question and we'll see if you can and see what might have happened or what you're thinking about with the tree diagram. Lou and Ali are on a fitness program for 1 month. The probability that Lou will finish the program successfully is 0.7, while the probability that Ali will finish it successfully is 0.6. The probability tree diagram shows this information. Draw a tree diagram to find the probability that only one of Lou and Ali will be successful. So that means we can only have 1 success, not 2 successes, or not 2 unsuccessfuls. So I think the tricky thing here was we're used to drawing our diagrams with picking things out of hats or previously like looking at different blood types. The difference here is we need to have, and it's probably in the last sentence, the last part of the last sentence, draw a tree diagram to find the probability that only one of Lou and Ali is successful. So we need to have Lou, as being one part of our tree and Ali as being the other. And we need to pop successful and unsuccessful in our tree. What people in class wanted to do was to pop a successful and unsuccessful here and then have Lou and Ali. But that doesn't happen. That doesn't work. So what these parts of our tree are up here are the things that are actually happening, or the events we are physically looking at. So we are physically looking at what happened with Lou and what happened with Ali, not what happened success and what happened unsuccess. So Lou was the first person we wanted to have a look at. We've got information of Lou being successful as 0.7. Therefore, because we need these to add to 1, unsuccessful for Lou has to be 0.3. We then put Ali in there and branched her off each side. And we know that the probability that Ali will finish is a 0.6. So that's a success. 0.6 is success for Ali. Unsuccessful for Ali is 0.4. And these have to add to 1. And the same down here. So that's our tree. And that was probably the hardest part of that. If we remember that we multiply across the tree and we add when we're going down, we're just about there. So we want to find the probability that only one of Lou and Ali is successful. So that would be a success and an unsuccess, and a success. So we're looking at that branch there and that branch there, and then we're going to add them together. 0.7 by 0.4 plus 0.3 by 0.6, add those together, and we get a probability of only one success as a 0.46. Okay, so that finishes off our little quick quiz questions and the examples in 10F. There are more examples to have a look at in the textbook under 10F if you would like to, but I would like you now to go and have a go at exercise 10F, reminding you that in our content and schedule tells you the questions that I would like you to have a go at. Make sure you're marking them and bring any questions that you have back to class. Thank you.